All right, here we're going to be talking about transformations. So, a transformation is changing a shape in some way in geometry. And you probably heard that word before. A transformer is a robot that changes into a car or back and forth. So, that's essentially what we're talking about, changing something. But in geometry, we're talking about changing a shape. So, we're going to be talking about two different transformations. The first one is a translation, which kind of sounds similar, which might make it confusing. Transformations is generally changing a shape. A translation is a specific kind where we slide a shape across. So transformations in general will change the size, location, or the orientation of a shape. So it can get bigger or smaller, it can move across the graph, or the orientation means it's turning or flipping. It's going to be pointing in a different direction. When we do this, the original shape is always called the pre-image. So in this picture, that's the original shape. That's called the pre-image, and it changes into the image. The new one is called the image. And without these words, let's say that wasn't written there, we would still know that this is the image and this is the pre-image because this is marked with the apostrophe. P with that apostrophe. The way we would read that, we would say that is prime. So we would say that's A prime, B prime, and C prime. So A prime, B prime, and C prime. The apostrophe tells you that that's the new point where that point ends up. All right, so let's get into our first one, which is called a translation. Translation is a slide from one location to another. You'll see that the pre-image just slides across the graph. We can represent this in three different ways. Verbally, just writing it in words. Algebraically, which is going to look like this. That's telling us what we're doing to the coordinates. And then graphically, that's the picture on the coordinate plane. So we have those three different ways to represent the exact same thing. Any of those three can be used. You really just have to read the instructions and see what we're looking for. So first we're going to start with a verbal representation. So a translation can be described with words like left, right, up, down. That's a simple way to say it. You might also see this written as horizontally or vertically. So horizontally means left and right. Vertically means up and down. In basketball, when they're scouting players or the NFL basketball or football, when they're scouting players, they want to decide how high they can jump. That's called a vertical. When you look out at the ocean and you see that line going straight across, that's called a horizon. So the horizon goes left to right. Somebody's vertical tells you how high up and down they can jump. So when I say I want to move this line segment PQ horizontally -8 and vertically +4, those instructions are really saying move this and this, those 2 points, horizontally -8 means move it left 8, and vertically +4 means move it up 4. So for each point, you're going to count using those instructions. I'm going to take point P and move it 1, 2, 3, 4, 5, 6, 7, 8 to the left. And I'm going to move it 4 up. So up 1, 2, 3, 4. That is the new location for P. It slid 8 to the left and 4 up. So the new spot is now -5, +4. Q moves 1, 2, 3, 4, 5, 6, 7, 8 left and 1, 2, 3, 4 up. Same instructions, move it 8 to the left, 4 up. And you can see it's the exact same line segment. Those look identical. It just slid across the graph. That's what I mean by slide. It slides that direction, 8 to the left and 4 up. So the new spot for Q, that's at -2, -2. The new X and the Y coordinates are -2, -2. All right, on the second one, we want to translate triangle EFG horizontally, +6. Horizontally, again, means left and right. When I see a positive number, that means I'm moving it to the right. So I'm going to move this to the right 6. And vertically, I'm moving -1. That means down 1. So I'm going to take each of these corners. Each one's called a vertex or a vertice, but I'm really just thinking about each point separately and moving it using these instructions. Go 1, 2, 3, 4, 5, 6 to the right and down 1. That's a new spot for E. F goes 1, 2, 3, 4, 5, 6 to the right, down 1. Same thing for G. 1, 2, 3, 4, 5, 6 to the right and down 1. All 3 points moved by the exact same amount, so we have the exact same triangle, it just slid over to the right. So E is at -2, -2. F is at +6, +1. And G is at 3, -9. All right, so that's when you're given verbal instructions on how to move your shape. We can also be given algebraic instructions. So algebraic basically means you're going to see some sort of variable in there. It might look complicated at first, but it's really the exact same thing that we just saw. This is just instructions on how to move left and right. Remember, the x-coordinate tells you how far left and right we are. The y-coordinate tells you how far up and down we are. So when I say I'm going to do something to the x-coordinate, that's going to move it left and right. When I say I'm going to do something to the y-coordinate, that's saying I'm going to go up and down. And you're just seeing that we're adding and subtracting based on whether we're moving left, right, or up or down. So x plus 5. I just want to translate that into words. So I just want to say exactly what does this say? When I say x plus 5, the x-coordinate dictates how far left and right we are. So if I say plus 5 to the x-coordinate, that means we're going to go to the right 5. The y-coordinate, that's the second number. That's telling us we're going to go up or down. If I say plus 2, that means I'm going to go up 2. So it's the same kind of instructions each time. This is telling us how far left and right. This is saying up and down. X minus 7, that says I'm going to go to the left 7. Y plus 10, that means I'm going to go up 10. All right, when I see x by itself, that means nothing is happening to the x-coordinate. I'm not moving left or right at all, so I don't have to do anything with that. I'm just moving the y-coordinate down 8. Y minus 8 means I'm moving down 8. Same thing the other way around. If nothing is happening to the y, you're not moving up and down. You're just following that set of instructions. X plus 1 means you move to the right one. So it's just a different way to write that information. You're still giving instructions on how to move a shape. Just instead of writing right, left, up, and down, you're writing it in terms of what's happening to the x and what's happening to the y. So we're going to go backwards here. We're writing this as an algebraic rule. I'm trying to translate this into a rule that looks like that. If I'm going to the right, that is adding. If I'm going down, that's subtracting. So right 6, that's changing the x value by 6. It's adding 6 to the x value. Down 2, that is subtracting 2 from the y value. Horizontally, -5. Horizontally means left and right. If I see a negative number there, that really means I'm moving left. Actually, it's not even that important that you understand that. I mean, you need to understand that, but really for writing the rule, you just need to understand that horizontally affects the x-coordinate. So x minus 5 is really what's happening there. And then vertically is affecting the y-coordinate. So I'm taking the y value and subtracting 4 from it. All right, so hopefully that clears up just what a rule like this really means. Now we're going to use that rule. So when I see x minus 2 and y minus 5, x minus 2. The x-coordinate tells us move left or right. So if I see a minus 2, that means I move to the left. Remember, all the x-coordinates are negative on that side. That's the left. All the x-coordinates are positive on that side. That's moving to the right. So if you see plus, that means you're moving to the right. If you see minus, that means we're moving to the left. So we move to the left 2. Y minus 5. That's saying I'm going to go down 5. So I'm going to take each of these corners. Each point is going to move using these instructions. I'm going to move to the left 2, 1, 2, and then down 1, 2, 3, 4, 5. E is going to do the same thing. Left 2, down 5. Same thing for F. Left 2, down 1, 2, 3, 4, 5. Same exact triangle. Nothing about the triangle changes except for where it is. The location is the only thing that changes. It slides down and to the left. Now I'm going to record those new coordinates. -1, -4 for D. F is easy because that's right in the middle. And then E is at 3, -3. All right, same kind of thing. I want to translate this into words, just so I know what that's saying. X plus 1 says go to the right 1. The x-coordinate is left and right. I'm adding, so that means I go to the right. Y minus 6, that means I'm going down 6. So D is going to move 1 to the right, and then 1, 2, 3, 4, 5, 6. Down, or sorry, to the right 1, and then down 6. And to the right 1, and down 1, 2, 3, 4, 5, 6. Same triangle. All that happened was it slid a little bit to the right and 6 down. So our new coordinates are at 2, -5, 6, -4, and 3, -1. All right, the last one's going to be going backwards. We're going to be given this picture and then have to describe it either algebraically or verbally. In both of these examples, really, we're going to describe the algebraic rule, which means we're writing it as x plus or minus something and y plus or minus something else. So I just want to basically think about what's happening to the shape and count. You have to know which one's the pre-image and which one's the image. This is just A. That is A prime. The apostrophe tells you that that's the new shape. So this is our pre-image. This is our image. From there to there, that's how we're counting. So you're just going to use one of these points. You don't need to use all of them because they're all going to be the same. Going from D to D prime, or B to B prime, or A to A prime, it's all the same. So I'm just going to use one of them, and I'm going to count really carefully, making sure I count each space. So from here, I'm going to count directly to the left. 1, 2, 3, 4, 5, 6 to the left. And then 1, 2, 3 up. All right, so that's a good verbal description, but now I want to write the rule. So I want to say what's happening to the x-coordinate. Well, I'm moving to the left, so I know I'm subtracting. So that's x minus 6. And then I'm moving the y-coordinate up, so I'm adding 3. That's y plus 3. On the next one, that is p prime. That means this is the new one. This is the old one. So I'm going from here to there. Looks like it's just going up. 1, 2, 3, 4. It's going up 4. It's not moving to the right at all. So nothing happens to the x value at all. We don't change the x value. We're just going up. So it's y plus 4. And on these last couple, we're kind of thinking about this as working backwards again, but instead of giving the graph, we're given some coordinates. So I want to think about what's happening to each of these x coordinates. So how do I go from 4 to 2, or 5 to 3, or 2 to 0? For each of those, we're going down 2. So the x coordinate is going down 2. Really, it means we're going to the left 2 in the picture. But I'm trying to write this as a rule, so I'm just thinking about what is happening to that x coordinate. Well, each time, we're subtracting 2 from the x coordinate. Same thing for the y coordinate, going from 2 to 5, 1 to 4. We're adding 3 each time. That means we're going up 3, because that's the y coordinate. So I'm adding 3 to each of these y coordinates. So that's y plus 3. All right, on number 4, translation moves point A to A prime. So I want to think about what's happening to get this new point. What's the image of point B, which is at 1, 4, under that same translation? So we're thinking about the same thing happening to B as whatever happened to A. So think about those x coordinates going from 3 to -5. 3 to -5. That's going down by 8. That's what's happening with the x coordinate. So the same thing is going to happen to this x coordinate. So this is the x coordinate for A. This x coordinate for B, the same thing's going to happen to it. I'm going to go down by 8. That means I'm going to go down to -7. The y coordinate's even easier because it's the exact same number. It's still going to be the exact same number there. 4 to 5. We're adding 1. So it's going to change from 4 to 5 again. Oh, I keep doing that. Didn't mean to put the parentheses there. It's still going to change from 4 to 5 because it's just going up by 1 again. So for the y coordinate, just to write it the same way, we're just adding 1. So that same thing's going to happen to the y coordinate of point B. All right, I hope this helps.